Hey all, we're going to talk about the second concept in Unit 5, the triangle inequality theorem. And we're going to talk today about what it really means to be a triangle. So the triangle inequality theorem just describes the relationship between the side lengths of any triangle. And what it says is that if you take the length of any two sides in a triangle, the sum, which means if you add them together, the sum of those two lengths should be greater than the length of the third side. So in order for us to be able to create a triangle, any two of the sides have to add up to be bigger than the length of the third side. So if we're given a picture of a triangle and we have labels for the sides, so here I have zx is 8, xy is 12, yz is 16. I really want to know, can I actually draw a triangle with those side lengths? So the triangle inequality theorem says that we should be able to add any two sides together, and they should be bigger than the third side. So let's do that. We'll pick two sides. I'll pick 8 and 12. 8 and 12 is 20. And then we have to compare that sum to the third side. 20 is greater than 16. So we're good so far. We could also pick 8 and 16. That gives us 24. That needs to be greater than 12, which it is. And last but not least, the other combination of sides would be 16 and 12. And that is 28. That needs to be greater than 8, which of course it is. So this triangle can exist because any two sides add up to be greater than. Remember, this is the greater than symbol. Any two sides that I pick add up and they are greater than the third side. A little hint here is if we look at each of these three additions, let's look at this one in blue in particular. 16 and 12 are the bigger two sides. Each of them by themselves are bigger than 8. So of course when you add them together, they'll be bigger than the third side. If we look at the red one, 16 is the biggest side, which means it's already bigger than 12. So once we add 8 to it, it's still going to be bigger. So the key to finding out whether or not a triangle can exist is really taking the smallest two side lengths, adding them together, and making sure that their sum is greater than the third side. So we can almost skip these two parts. So go ahead and pause the video and find out if this triangle can exist with these three side lengths. So like I said on the last slide, any two of these sides should add up to be bigger than the third. But kind of a shortcut, kind of a hint I gave you is to take the two smallest sides, so 9 and 7, and we'll add those together. And we get 16. And we need those two sides to be greater than the third side. So we need 16, the sum of the two small sides, to be greater than the other side. Now, it's not smaller. 16 is not smaller than 16, but it's also not greater than. So this does not work. So I cannot actually make a triangle with sides 9, 7, and 16. So this triangle does not exist. Now, even though I drew a triangle and labeled these sides, I didn't draw them to scale. I just labeled the numbers. So this triangle is not drawn to scale. So I could not actually draw a triangle with these three side lengths. We could also find the range of possible values. Oops, sorry about that. For a third side length using the triangle inequality theorem. So the way that we determine the possible length of this side, this question mark, the one we're looking for, is by using the two sides we're given. So this question mark, and we're looking for a range, so that means we're going to have some sort of inequality. This question mark is going to be smaller than some value, so less than some value, and it's going to be greater than some value. To find the value that goes here, that starts the inequality, we'll just take those two and subtract them, 19 minus 13, and we get 6. To find the number that goes here at the end of the inequality, we'll add these two. So we get 19 plus 13, and that gives us 32. So the value of our third side must be bigger than 6 and smaller than 32. And that's because if we add these two sides together, they need to be bigger than the third side. So when we add 19 and 13, they give us 32. So that means this side has to be smaller than 32, or we can't have a triangle. Also, if I take 6, if I have 6 as the side, and I add 6 to 13, it will give me 19. And that's going to be like in the example we did earlier. 19 is equal to 19, but it's not greater than 19, so that doesn't work. So again, a quick way to find the range is to subtract the two sides and then add the two sides, and we'll get an inequality like this. Let's go ahead and pause the video here and see if you can find the range of possible values for this side question mark. So again, we're going to have an inequality. That side is going to be less than some value and greater than some other value. We find the first piece by subtracting those, 21 minus 9. And we find the second piece by adding them. So 21 minus 9 gives us 12. 21 plus 9 gives us 30. That means that the third side of this triangle must be bigger than 12, and it also must be less than 30. So for example, we could have a side length of 13, we could have a side length of 29, we could have a side length of 29.5 if we wanted to, just as long as it's less than 30 or greater than 12. So this would be our answer right here. And these would be some examples if I asked you for an example of a possible third side length. So go ahead and try these two problems, and we will discuss them in class.